SNU-MSE, the Department of Material Science and Engineering at Seoul National University, the most prestigious and largest university in South Korea, has played a leading role in material research in Korea. The Department of Material Science and Engineering was formed by combining three disciplines: metallurgy, textile and polymer, and inorganic materials engineering. For that reason, SNU-MSE covers most of the areas in material research with 43 full-time faculties and about 1,000 undergraduate and graduate students. Over the past 60 years, there has been an unprecedented economic growth in Korea. Korea is regarded the only country worldwide that managed to become a creditor country from an emerging market economy. During that transition, SNU-MSE has carried out a major role in the growth of the country by providing a well-educated and talented workforces as well as the important research results to the industry. We have led and supported the industries in Korea, including iron and steel making, semiconductors, displays, automobiles, and shipbuilding. Naturally, collaborative research and development programs are well developed with the major industries in Korea such as Samsung, LG, POSCO, and Hyundai, which did contribute to the change of Korea and the world.
The most important role of university is to supply high-caliber researchers and engineers to cope with future challenges in semiconductor industry. As the semiconductor devices scales down, materials and processing-related issues becoming more and more important in semiconductor manufacturing. We need to find out new materials for switching devices for low power consumption. We need to develop new processing techniques for next generation logic devices, CPUs, GPUs, memories, etc. In this sense, research and education at SNU-MSE makes our graduate students to prepare for the future challenges in semiconductor industry.
Although people are excited in the electronic gadget, like iPhone here, we cannot live without the structural material. We commute from home to school by bus, subway, so we cannot actually live without the structural material, and structural material is and in East Asian country, including Korea, there are many world-leading companies in producing the materials like steel, aluminum, and magnesium, and so we have the mandate to educate the student and the research for the structural material field. Overall, I would like to say that our department put a great effort to advance structural material field, not only for our department actually, it's also for the entire human society in the future.
For the sustainable society and economy, one of the critical matters is that how we can attain sustainable energy generation and storage strategies. For a long time, our department has tackled these issues with a close tie to the industry through proposing new concepts or new approaches for energy devices, or by developing breakthrough materials that can boost the performance of these kind of devices. In our major research, energy research area, rechargeable batteries, we are actively collaborating with world-leading battery manufacturers such as Samsung, LG Chemistry, and Hyundai Motors for future electric vehicles. We are trying to focus on the post-lithium-ion battery, especially on the metal gas battery system, which actually uses the gases like oxygen, airs in the development of high energy density batteries.
So recently we made an amazing breakthrough in material science by using peptide for the synthesis of nanomaterials. Actually, the concept of chirality is a central theme in chemistry. Chirality can be everywhere in nature, and the chirality is a key feature in living organism, from DNA and peptide and even shells. So recently, we utilized the concept of chirality in peptide to make precisely control the three-dimensional nanostructures.
Yeah, our department includes teaching and research activities related to various aspects of organic and polymer science engineering. The other activity is we want to emulate the biological nerve in our body. So therefore, we demonstrate two different sensory nerve systems. The first one is mechanosensory nervous system, and the other one is light sensory nervous system. We can actually move the artificial muscles using our optoelectronic artificial synapse. We believe this kind of development of artificial sensory motor neural system made of organic electronics will create next paradigm for bio-inspired soft electronics and neurorobotics and neuroprosthetics.
The key strategy of our department is balance. Research in material science aims at the balance of research topics, and we also strive a good balance between education and research, between basic science and engineering, between domestic and global issues, between classic and emergent materials, between structural, electronic, bio, and energy materials. For the future, we hope and expect that the contributions from SNU-MSE will become more visible and more influential to the material research society around the globe.